In Algebra 2, section 6.4, we're starting now with nth root. So it's not just square roots we're dealing with, but with nth root as well. So when you're dealing with a square root sign, you're always assuming that the index n is 2. So basically any two numbers when multiplied together gets you 81, right? So 9 times 9 equals 81, so the square root of 81 is, is 9. Now this, if there's not there, we're assuming it's 2, okay? But typically, you can put any number there, and it is called the index, and the index is currency. It's basically telling me how many sets. If this was a 2, then it means I need a set of two of the same numbers in order to bring it out as 1. For example, if I have 3, that means I need a set of 3 numbers that are the same that I can bring out on the outside of the radical sign. It represents 1. So this tells me how many sets and the inside do I need in order to bring out 1 of that value. So, for example, the cubed root of 32, I'm going to take 32 and factor it. I'm going to factor it down 2 times 2 times 2 times 2, right? 8 times 4 is still 32. I factor it down to its factors, and that's 5 2s. So this is my index, okay? It's not 3 times this, it's the nth root. So basically, the index is saying that I need 3 of the same numbers in order to bring out. Well, if I took out one set of 3 2s, it comes out as just 1 2 on the outside. Well, the other one doesn't have another set of 2s, so that means I have to leave that in there. So my answer would be 2, right? And then cube root of 4. I'm going to write that again. So it's 2 cube root of 4. Because I multiply the leftovers together. Now, let's say I had another 2 in there. Let's say I was doing the cube root of 64. Well, this 64 is 32 times 2, which is 8 times 4, which is 4 times 2, which is 2 times 2. And this is 2 times 2. So that's 1, 2, 3, 4, 5, 6 2s. So cube root of 2 times 2 times 2 times 2 times 2 times 2, right? So the index says every set of 3s. So I have one set of 3. That becomes 1 2 on the outside, and another set of 3 2s, which is on the outside. Nothing else is left on the inside. Since nothing else is left on the inside, I just multiply what's on the outside, which is 2 and 2, which is 4. Okay? What that's telling me is I do 4 times 4 times 4. It should give me 64 on the inside. Okay? So go ahead and pause and write this down. Hopefully it makes sense, and we're going to try some example problems together. Okay, so plus or minus. So there's no number out here, so I'm going to assume that my index is 2. So basically, I just need sets. So if I broke 16 down, it's 8 times 4, 2 times 2, 4 times 2, and 2 times 2. So 1, 2, 3, 4, 5. So I have 5 2s. 1, 2, 3, no. It's not 8 times 4, it's 8 times 2. So I have 4 2s, and then 8 x's. 2, 3, 4, 5, 6, 7, 8. Okay? So I can take out any sets of 2s. So this is 1, 2, 3, I mean an x, another x, another x, and another x. And then, since there's nothing else left over, I've circled everything, then nothing's in the square root. I just multiply this out. 2 times 2 is 4, and this is x to the 4th. plus or minus. Got to carry that plus or minus down. So an easy way to do variables is just take the exponent and divide it by the index. And if this was square root of x to the 9th, right, I can just do the square root of x to the 8th times x to the 9th, times x, because this would still be x to the 9th, and then I would divide it because this is divisible. 9 isn't divisible by 2, but 8 is, and then I'll have 1 left over. So that's a way that I can do it, or if this makes sense, you can stick to this. It's just a lot of writing. The next one is basically also sets of 2. Now it seems like a lot because we have the parentheses, but the parentheses is perfect. It just means it's cubed plus 5 plus 5 I'm going to take it parentheses at a time. So if I have 4 of those and this is 2, I'm going to bring the negative down and it's just a set of 2. Here's one set of 2. So it's cubed plus 5 and another set of 2. Cubed plus 5. So basically this is negative q cubed plus 5 squared. So I take it as parentheses, so I don't have to take it individually because it's a little more complicated if I want to take it individually. I'd have to multiply all of these out in order to do that. Now, I can only do that because of the parentheses. If this 4 was attached to the 5 and the 3 to the q, then I couldn't do that because the 4 was not attached to the whole thing, just to the 5. The next one here, I'm going to do what I'm learning here. I'm going to take that exponent and divide it by 5. This is supposed to be an s. BT dubs. Okay, so I'm going to take 24. I'm going to do 6 times 4, 3 times 2, 2 times 2. Oh, I can't take anything out of 24. 3, 2, 2, 2. This is a 5 on there. So I have to leave 24 in there. But 10 is divisible by 5, right? So I have 2 sets. So this would be 2 a's, a to the 10th, s to the 15th. So that means I have a to the 5, another a to the 5. What that means is that if I take 10 and divide it by the index 5, I'll have 2 a's on the outside. And then this one I'll have 3 s's on the outside. Because 15 divided by 5 is 3. I have square root of 24 on the inside, but these are all on the outside. I have a squared s cubed. Now 4, when we have a negative in there, this becomes an imaginary number. So it's the square root of 4i, which is 2i. So hopefully that kind of clarifies the rules of what the index does and what you're looking for. Go ahead and pause this, write it down. You're doing page 409, numbers 4 and 6, page 409, numbers 4 and 6, and I will see you in class.